Hello Internet. In the previous video, the maximum logical keys of the Arduino Pro Micro HMI are around 200 plus. To increase the numbers of logical keys, I would like to try a more powerful microcontroller for the HMI keypad project as a promise. As upgrading from Arduino IDE, I would like to try STM32. There are two branches of the Arduino-like programming. One is STM32 Duino by ST Microelectronics. The other one is by Roger Clark, which bases on Leaflabs Maple. Here I use STM32 Duino in this demonstration. Here is a keyboard simulation program. Choose the STM32 F1 series here. Choose Blue Pill F103C8 here. USB support HID, keyboard and mouse. I use ST-Link V2 to upload the program. Press here to compile and upload. Complete uploading. Use a micro USB cable to connect the blue pill. The keyboard simulation works as expected. In case the simulation does not work, you may try a different USB cable or replace the pull-up resistor. Here is the design of the Arduino Pro Micro PCB. Arduino Pro Micro here. 12 physical buttons. 6 profile switching buttons. Here is the design of the STM32 PCB. The microcontroller is built in for easy rooting. 6 profile switching buttons. 20 physical buttons. A rotary encoder. I assemble the PCB by hand soldering. It depends on the previous settings of the microcontroller. In some circumstances, you may not connect the microcontroller by ST-Link. Then, you have to reset the microcontroller by USB to a serial interface. Microcontroller, TX, to USB serial, RX. Microcontroller, RX, to USB serial, TX. Connect ground and VCC. Download and install the STM32 Flash loader demonstrator from ST Microelectronics. In my case, the USB serial is COM3. Move boot 0 jumper to the right position. Press the reset button. Click Next on the Flash loader demonstrator. Select Erase All. Move boot 0 jumper to the left position. Complete the reset process. Under STM32 Duino or Leaf Maple, GPIO A15, B3, B4 do no work as expected. Referring to JTAG in the reference manual, it needs to change the setting of the AFIOMAPR register. In STM32 Duino, you need to change the register like this. In Leaflab Maple, you need to change the register like this. F13 to F24 does no works as expected. This sample code simulates pressing the F12 key. Wait for a second, press the F13 key. Wait for a second and loop back to pressing the F12 key. F12 works, but F13 does not work. I also try Roger Clark, Leaflab Maple. The code is a little bit different from STM32 Duino. However, F13 also does not work. Then, I download STM32 Cube IDE and try Matej Blagsic HID keyboard device, HID with USB report descriptor 63 bytes, it does not work. Then, I tried the Victor Vano code, HID with USB report descriptor 78 bytes, it does not work. I posted this issue to the STM32 Duino forum, but it seems that no reply after a month. What a frustrating experience it is. Until I found a blog from Damogran Labs. Custom HID with USB report descriptor 45 bytes. Here is the sample code. Same as before. Press F12. Wait for 1 second. Press F13. Wait for 1 second and loop back to F12. It works. Unlike Arduino, I have to write the serial communication to Next-Gen HMI from scratch. Finally, when I designed the custom PCB, I did not know that STM32 has a built-in hardware encoder feature. Because of my carelessness, I use 2 jumpers to connect the rotary encoder. STM32F103 is more robust than ATmega32U4. Arduino program and library work like a charm. STM32 has fewer resources and libraries. Hope this video will help someone about STM32. Thanks for watching. If you like this video, please like, share, and subscribe. See you next time.